In this lesson, we're going to do some practice questions for the work that we did so far. It's not that much, and we're going to incorporate some of the previous questions or redo some of the previous questions that we did before. So, the first question that I have to answer is, what is the most suitable instrument to measure the external diameter of a pipe? Now, this is best done by the use of a vernier caliper. And I already told you to go and try and learn how to use a vernier caliper. And I think later on I will actually show you all how to read a vernier caliper. But for those who wish to take the initiative, you can see this is what a vernier caliper looks like, and this is the source that I'm going to get the information from when I'm doing the vernier caliper. Alright, now you can see right away that there's some jaws here that you can actually use to determine internal diameters, and then you can have these outer jaws here that you can use for outer dimensions, for outer diameters. Alright, and you can see the vernier scale right here. The next question is, what is the best instrument to measure the diameter of a strand of hair? And the answer to that is a micrometer screw gauge. Now again, you're supposed to go and learn how to read these, but I'll probably do a lesson later on. This is what a micrometer screw gauge looks like. And this is the source that I'm going to be taking the information from to show you how to read a micrometer screw gauge. Alright, so you can see the ratchet knob, the main thimble, and then you have the lock and then the spindles that enclose the object that you would be measuring the dimensions of. Question number 3, what is the length of the rod in the left end of the rod? What is the length of the rod if the left end of the rod is at 0? So the left end of this rod is at 0, and this is the ruler that I have here, and I'm checking it out. It is 7.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7. In between 0.7 and 0.8, but we see up until 0.7. So we're going to say it's closest to 0.7 for my case. And then I am going to actually try and see what is the smallest division, and I can see that each division here is a 0.1 division. So 0.1 divisions, and I'm dividing that by 2, and I get the answer of 0.05. So I'm going to say that the dimension of this, and I think that this ruler here is measuring in centimeters. So I'm going to say it is 7.7 plus or minus 0.05 centimeters. And that here is supposed to have a centimeters at the end. Sorry, I'm just filling that if you're taking this down. Alright, notice that I actually stated the uncertainty in the value that I am actually given 7.7. Alright, next question. This is one that we did previously. An airplane is traveling at 83.3 meters per second. Is it traveling faster than a car that is going 140 kilometers per hour? And as I said before, this requires that you convert units from one to the next. So we are going to convert the kilometers per hour unit that we have here into meters per second over here, and then we're going to compare the values that we have. So you will end up with this. As I said, first off, you write it as if you would write a fraction. So we put the 140 km and the h to the minus 1 part. We're going to actually just write it on the underneath as just h to the power of 1 in the C rules. And next we're going to convert each one of the units that we see in here. So we see in an hour and we see in a kilometers. So we start with kilometers first. We are going to choose a convenient number of 1. So kilometers, we're going to write it in such a way that km's could cancel, and you can see right here km cancels with km, and 1 kilometer is equal to 1,000 meters. So we have the 1,000 m on the top. Then we're going to multiply again 1 hour upon 3,600 seconds, and notice here again the h that is on the underneath, we are writing the convenient value of 1 in such a way that the h is on top so that we can cancel it. Notice now that we have 1401,000 m divided by 3,600 s, and we have an answer of 338 and 8/9 meters per second. Now that each of the units of the values are in the same, then all we have to do is just simply compare the value that we have associated with it. Notice that this value here is less than the value of the airplane here. So therefore, the car is not traveling faster than the airplane. Alright, so if you have any questions for me, you can simply send me a message or leave a comment. Thank you.